And I'm a recitation leader for 995. We're going to go over the stuff for CBE 4. So in CBE 4, it covers sets and notations for sets, solving solutions of equations, and properties of equality. If I can speak English, this is going to be way easier, guys. Solving linear equations, solving absolute value equations, solving equations using the zero factor property, solving rational equations, and solving equations with radical terms. We're going to go over each one of those individually. So we're going to start with sets and notations for sets. And so there's a lot with the notation. So for interval notation, which is when you write it as the numbers so that you have an interval, like so, that is what interval notation looks like. So you'll have the numbers for what it is supposed to equal or be less than or greater than. So if you have a parenthesis, it means that it's not equivalent to. And if you have a bracket, it means that it is equivalent. So 9 is an answer in this example, but 0 is not an answer. And then you start with the lowest number and go to the higher number. So it would not be correct if I were to write 9, 0. That would be an incorrect notation there. All right. So we do not do that. Now, if we're lucky, this just erases. Nope. Nope.
Just go on the next slide if we just move on.
I think it will, but so start with the lowest number and connecting intervals with a U, which do not use a U on your keyboard. Use the U that is provided within the little pop-up keyboard. Yes. All right, so for our first problem, we're describing a set of all real numbers that are greater than or equal to 3 and less than or equal to 18 using interval notation. So how do we do this?
So with equal to, you have the closed bracket.
So we get a closed bracket to 3 and less than or equal to 18.
This is where I mess up constantly. I always mix up greater than a less than. So greater than, it's pointing toward, the open part is pointing towards the 3, correct? Or is that less than?
So if we were to write this in this notation, greater than or equal to 3.
Okay, yeah.
X is greater than or equal to 3. So it would go the opposite way.
Okay.
So X is greater than or equal to 3. And then less than or equal to 18.
Okay, that makes
sense.
Okay.
So whatever is the first one for greater, you're going to put. I always think of it as a crocodile. I was taught as a crocodile, okay?
Yeah, I would
So
as well.
if the crocodile would be facing towards what is larger.
Okay.
Yes. Because it wants to always eat more.
All right.
Yep. Okay. So finishing our interval notation. We got bracket 3, comma 18.
And then another bracket.
Another bracket. Yes. Do we have any questions on that? Wonderful. And we are correct. So way to go, us.
Great.
Yay. All right.
Cool. Moving on, next few questions. CBE 4 goes with solving linear equations. Evidently, you can go backwards when you just tap on it. So with solving linear equations, a solution is any value of x that makes the equation true. So we're going to have, some numbers, maybe some x's equal something else. We want to find what x is to make that true. Linear equations are equations where the variable is only to the first power, no exponent, Right, so we're going to get x's. We will not get like x squareds or anything like that in linear equations. Linear equations usually have one solution, but they may have no solutions or infinitely many solutions. So most of the time you're going to get just x equals one number. You may get something where the x goes away and you get like 0 equals 5. And in that case, it's no solutions because 0 doesn't equal 5. And if you get something where it's like 0 equals 0, that means all solutions, x could be anything, because 0 does in fact equal 0 no matter what x is, because x no longer would exist in that. So to solve these, we're going to find the solutions by unpeeling what is happening to the variable. Need to maintain equality. So what you do on one side, you do to the other. If you add 5 on one side, you have to add 5 to the other side. And rewrite to get variable equals a value. So you're going to try to get x is all on one side, solve for x, everything else on the other side. So we go ahead and got this problem right here. Kind of work through it. So what's kind of a first step we want to be able to work through this problem?
Get all the x's on one side.
Yep, get all the x's on one side. We're going ahead. I like to keep my numbers positive. It doesn't matter what side you get it on as long as you don't break any rules with that. To do that, I'm going to add 2/5 x to this side to get rid of the x on that side. On the left side, you need to do the same thing. So 4/5 plus 2/5, they have the same denominator. We add the top, we're going to get 6/5 x. And we're left with plus 3 equals -9. Okay. How do we want to go about this now?
I would remove 3, so -3.
Yep, -3 from both sides, right? Get x is all on one side, everything without an x on the other side. -9 minus 3 is -12. Okay. And what's our last step we need to do in this?
Times it by 5.
Yep, times everything by 5. Start that. 6x equals -60. And then anything else we need to do?
Divide by 6.
Divide by 6, right. Nice and easy. Divide by 6. All right, get x all by itself, no numbers in front of it. We left with that. We got x equals -10. Move on. Our solution's over our work, but x equals -10 inside. Cool. Want me to do?
You can do it.
Cool.
All right. For this one, what do we want to do first?
I would multiply the 3 out on the left side and on the right side. Multiply the 5 out.
All right, so what do you get?
12x minus 15 plus 8 equals 15 minus 15x.
All right. And what would you do next?
Combine like terms for each side. So combine -15 and 8.
And after that?
I would take 12, or I would take 15 and say plus 15x, and then on the other side do plus 7 to the other side.
And our last step?
Divide out the 27.
And I don't believe it can be simplified past that.
Yes, I agree. And we are correct.
Hallelujah. Cool. Before going, any questions about solving system linear equations? Seem like you guys got it. Hopefully the people that watch this YouTube video got it. So we're going to move on to solving absolute value equations. Kind of first going with absolute values. Absolute value is the distance from 0, so it is never negative. Whatever is in it, it's always going to become a positive number. This applies to the entire expression. So if you have 5x plus 3 all in absolute values, that whole quantity will end up not being negative. You can still have negative numbers in it, but then they become positive. So yeah, not in each individual number. So we're going to start out by first, to find the solutions, by first isolating the absolute value, make it by itself. And then we need to remember absolute values cannot evaluate to a negative. So if you get the absolute value equals like a -2 or something, then there's no solutions. And assuming it is positive at the end, then what we're going to do is set up two equations where it's what was in the absolute value equals the positive number, what's in the absolute value equals the negative of whatever number it equaled. Yeah, go ahead and got this problem right here. So with that, what do we want to do first? This absolute value problem.
I would subtract the 9.
Yep, subtract the 9. Helps us isolate the absolute value a little bit more. -5. Okay, and then what do we want to do from here?
We have to get the absolute value by itself, so divide by 6.
Yep, divide by 6. Isolated. Okay, so we got our absolute value is now isolated. We equal -5, 6. Okay, and then what do we want to do from here? Okay.
I like to separate it out like a triangle and then do one side that's negative, and then the other side that's the positive side of the absolute.
Yep.
Trying to get rid of the absolute.
Yeah, so that's what we're going to want to do if it's positive. But first, can the absolute value be a negative number when it comes out? So if we were to put any x in, right, will that number be a negative number or will it always be a positive number?
Always a positive?
It's always going to be a positive, no matter what x is. X could be -1,000,000. We're going to get negative some odd thing in the absolute value, but then it becomes a positive number. So can an absolute value ever equal -5, 6?
Oh, yeah, no.
No, right. We got -5, 6 on the right side. So in this case, it's going to be no solutions. So before you separate out, that's what you're going to want to check first. It's, okay, what's on the right side of my equation? Is it positive? Is it negative? If it's positive, then yes, you want to separate that out. One positive, one negative. But in this case, the absolute value can't become a -5, 6, no matter what. So, make sense? Any questions? Perfect. So yep, no solutions.
All right. So how do we want to start this problem?
By adding 10 both sides.
Why would I set my hand on it? Seems like, but that's okay. And then, what do we want to do next?
Divide out 3.
Divide. All right. How many solutions are we going to get? 2. Why?
Because it doesn't equal 0, and the other option is that if it's negative, then it's no solution. So it has to be 2 solutions.
2 solutions. All right. So what are our 2 equations?
So 4x plus 5 equals 4. And then is it -4x plus 5 equals 4?
Close. It's going to be you're going to keep the same stuff that was in the absolute value, but you're going to change what it equals to be the positive and the negative. So you're going to get a -4.
Okay.
Yes. All right. And then we'll solve the one that equals +4 first. What do we do?
Subtract out the 5.
Subtract the 5. 4x equals -1. And then what do we do next? What is the next step?
It would be divided by 4.
Divide by 4. So x equals a negative 1/4. And on the other side, we're going to follow the exact same steps. So first we subtracted 5, which is going to get us a negative 9. And after that we divided by 4. So x is going to equal a negative 9/4. And with the absolute value ones especially, we are going to have to go through and check our answers. Do we know how to check our answers? No? That's all right. We are going, all you do when you're checking your answers is whatever you got x to equal, you're going to plug it back into the equation. And so we are going to check that 3 times 4 times our answer, which is for our x, which is negative 1/4, plus 5 minus 10 is going to equal 2. So then we're just going to follow order of operations to make sure this equation is true. So what would we do first as we are solving?
Get rid of the 10 again. Or wait, no, we're not peeling it back.
Okay. Distribute your 4 into your negative 4, 1/4. Okay. And then negative 1 plus 5 is going to get us a positive 4 minus 10 is going to equal 2. The absolute value of 4, what is the absolute value of 4? 4. So you get 3 times 4 minus 10 equals 2. 3 times 4 is 12 minus 10 equals 2. So that one's good. We know that it equals negative 4. We just checked it. And you do the same process for negative 9/4. Do we want to check negative 9/4 also? Yeah. Okay. Let's do it. I'm running out of space. So we're going to see if I can figure out how to erase.
Go forward and back.
Maybe. I feel like, is it one of the ones that will erase like that? Nope.
Evidently not. It does not like you.
It doesn't give me those
Like
options.
you use 2 fingers and like double tap.
No.
Nope. Okay. I just scribbled all the way through our previous work, but that's okay.
It's fine.
We're just gonna write, and we're gonna kind of go lengthwise over here, and we're gonna see if this is gonna work out. So 4 times our solution, which is negative 9/4 plus 5. Close your absolute values minus 10. It's going to equal 2. So as we're simplifying, what do we simplify first?
4 times negative 9/4.
Yes. And what do we get? What's 4 times negative 9/4?
Drawing blank.
Negative 36 over 4.
And can we simplify it?
We can divide it by 2, which would be negative 18 over 2, and we can divide it by 2 again, so it'd be negative 9 over 1.
Which is just negative 9. You can also see here that we can simplify across, right? So this divided by this is going to equal 1. And so negative 9 over 1 is going to. So either way, we
Okay.
multiply it across, and it works. We get the same answer both ways, okay? Then we're going to add 5 minus 10 equals 2. So negative 9 plus 5 is going to equal negative 4 minus 10 equals 2. So what's the absolute value of negative 4?
4.
4. So 3 times 4 minus 10 equals 2. 3 3 times 4 is 12 minus 10 equals 2. So that one works also. So we know they're both solutions. Do we have any questions on your absolute values or how to check solutions? Wonderful. We're gonna get rid of that mess.
Yes. Okay. Moving on, next couple problems we'll do is on solving equations with the zero factor property. And what that is just saying that any number multiplied by 0 is 0. If the product of two or more numbers is equal to 0, then at least one of the numbers must be equal to 0. How this can come into play is when we're gonna have like something factored equals 0. If one of those factors, if we can set x to equal 0 for one of those factors, then that is a solution for x. And then also like another solution be for the other factor. As long as one of those equals 0, if it's multiplied by everything, the answer is 0. So to solve this, first we're gonna get all numbers on one side, so everything is equal to 0. Then we're gonna factor, right? So then we have our factors, and then set each individual factor equal to 0 and solve. This comes into play as we could see when you have something with like an x squared in it, or an x cubed. That's where we're gonna want to be able to use this property. So to begin out, one thing I like to check before I really even move anything around is there anything we could simplify to make this equation easier? Anything we could like divide them by or multiply by to make it easier?
We can take out 5.
Right, we could take out 5. So we divide 5 from each term. Then we're going to get an x squared plus 6 equals negative 5x. I like it. As we can see, hey, look, our equation is now smaller numbers. Usually that makes it easier to solve. Okay, what's our next step we want to do? Solving this equation.
Add the 5x to the left side, so we could set it equal to 0.
Exactly. We got an x squared in there, so we want to use our zero factor property. So we're going to get an x squared plus 5x plus 6. Right in descending order makes everything a lot easier to see. And now nothing's on that right side, so it's equal to 0. Perfect. What's our next step we want to do? Factor, right? So we see this. This one factors pretty nicely. So what two numbers multiply to 6 and add to 5?
3 and 2.
3 and 2, right? And we have just a 1 on our first thing, so it just comes out to x plus 2 and x plus 3. This is still equal to 0, right? And so now what we want to do to solve for our x's.
If we put a negative 2 for x, it would be 0, and then that would be one of the solutions. Yep,
exactly. So we want to set each factor to 0. If we look at our factor on the left, right, x is equal to negative 2 for that one. Set our one on the right, so x plus 3 equals 0. Subtract the 3 over, we get x is equal to negative 3. And that is going to be our two solutions on this one. So any questions about how you got there? Seems like you guys got the process pretty well down of move everything, factor, set factors to 0. Perfect.
All right. So next, we're going to practice solving rational equations. And so our rational equation are just big fraction problems. And so we usually begin.
It's supposed to be begin.
Okay. I thought so. We usually begin by adding the fractions, making a common denominator as needed. And so first, find your least common denominator. Then you're going to multiply by your least common denominator so that you get rid of your fraction. And then you're going to solve the remaining equation and check your answers to make sure that you don't have any extraneous solutions. So here's our first problem. What do we want to do first?
We want to find the lowest common denominator, right?
Yes. I like to start by first simplifying each one of my fractions if it is possible so that we can get the smallest denominator possible. So if we see here, we have a 3 times a quantity divided by 3. So we can divide these to 1 and get x minus 6 over 1 equals 3 times x plus 1 over 8. So what would our least common denominator be?
8.
8. So we're going to multiply the whole equation by 8. So you get 8 times x minus 6 is going to equal here 8 divided by 8 is going to equal 1. So you just end up with 3 times x plus 1. So what do we do once we get here?
We gotta multiply the 8 and multiply the 3.
We're going to distribute.
Oh, sorry.
Yes. That is exactly what you just explained, which is we're just going to distribute. So 8 times x is 8x. 8 times a negative 6 is a negative 48. 3 times x is 3x. And 3 times 1 is 3. So what are we going to do next?
I would subtract 3x and then add the 48.
So you get 5x equals 51. And what is our next step?
Divide out the 5.
Divide by 5. So x equals 51 over 5. And then we need to check to make sure it's not an extraneous solution. So we're going to go back through and check our answers, which for these ones can be a lot of fractions, but we've got it. 51, 5, minus 6. So how are we going to simplify? Where do we start?
Can we cancel out the 3's again? Or
Yes, we can. Those will divide to 1. So you get 51 over 5 minus 6 is equal to 3 times 51 over 5 plus 1 all over 8. Where else can we simplify?
Can we times both sides by 8 again, or no? To get rid of that, divide by 8.
We could. What I think is going to end up being a little bit easier is if we find a common denominator within our parentheses
so
and simplify within. So what would our common denominator be?
What would be 5?
5. So you had 51 over 5 minus 30 over 5. And then you get 3 times 51 over 5 plus 5 over 5 all over 8. So 51 minus 30 is going to get us 21 fifths. And here we get 3. And this will be 56 fifths over 8. So then
We can find the lowest common denominator again. Or
No.
do,
we're only multiplying and dividing, so we're not going to need to find another common denominator. The 21 fifths is going to stay 21 fifths. There's no way we can simplify it. The you're going to end up multiplying your 3 through your 56/5, which is going to equal 168 over 5. And I'm going to rewrite our dividing by 8 as 1/8, because that's going to be the same thing. And then you get 68, and you can divide across here, and you can get 1. And 8 times 21 equals 168. So you do get 21/5 equals 21/5. So our solution is a valid solution. It's going to work.
Okay. Got another one of these problems. This one just looks a little different because we got an x in a denominator, but process is still going to be the same. So what do we want to do first when we got these fraction problems?
Is this another one where we find the lowest common?
It is another one where we find the lowest common denominator, right? We don't like fractions. Fractions suck. We want to get rid of our fractions. Okay. What is the lowest common denominator in this one, though?
Would it be 18x?
It'd be 18x, right? We have an x in our denominators, so that could still be in our least common denominators. So we take this whole fraction, right, times it by 18x, right? That's our lowest common denominator. So in this first one, we got 3/2 times 18x. What do we end up with? Get an x in there. So we got 3 times by 18 divided by 2. Kind of a big number. One thing you can think about is we could do 18 divided by 2 first. So that's going to give us 9. 9 times by 8, or 9 times 3 is 27. Awesome. And you do get a simple calculator. So if you have those big multiplication numbers, always throw it on there. Okay, we got our second term. 12 divided by x times by 18x. What happens to our x in the denominator? Goes away.
So it cancels.
Yep,
out.
it cancels out with that x from the 18. So we get 12 times by 18. That one is one I don't have that memorized. I don't know if you guys do. It's 216 in the calculator. Then our last one, we got 5 divided by 18 times by 18x. And what are we left with there? Just 5x, right? 18's go away. And then this is equal to 1 times by 18x, which is 18x. Good? Okay, now we just got kind of this linear system or linear equation. So how do we want to go about solving this?
We can add the x's first.
Yep, add the x's first. Do you want to put them on the left or the right?
Put it on the right.
Put it on the right.
So I guess minus 5x.
Yep, minus 5x. And minus the 27x as well. Nice, so we're going to get 216 is just left on that side. Again, 18 minus 5 minus 27 is negative 14. X. Okay. And what's our last step we need to do?
We need to divide by 14.
Yep, divide by negative 14.
Negative 14.
All right, we want x to be a positive when we get done with it. So negative 14. X is now by itself, so we get writing it back to the left side. You could flip it around like that, or you could just have something equals x. But we're going to get 216 by negative 14. Awesome.
That's not a whole.
This should be able to simplify it now.
Yep, it should be able to simplify. What can we take out of this to simplify it?
We can take out a 2.
We can take out a 2, right? Take out 2. 216 divided by 2 is 108. 14 divided by 2 is 7. We still got our negative sticking around. Do you think there's anything else we could take out of that?
I don't think so.
Don't think so. only a 7 could come out. So if you want to check, you throw in your calculator. 108 divided by 7 is not going to be a whole number. So that's where we get done with is x equals negative 108 divided by 7. You can go back and check your answer. Actually comes out with linear equations like this. You should if you did everything right, that should be your answer. There's other equations where you do need to check because it will come out with extra answers. Do we want to check this one? It's a little complicated. It throws a negative in the bottom, or fraction in the bottom, but maybe good practice. You think
We're good.
good?
Yeah.
Feel good about these?
I'll extend it.
It's still good practice on CBEs. Do check some answers like this. Because if it comes out right, you know you got the right answer every time. Yeah.
All
One more.
So for this one, it looks a little different than any of the other ones that we have done so far. So what do we want to do first?
Do we need to factor out the middle? Would that make it easier for us to solve?
If we factor the denominator in the middle?
Yes.
Yes. If we're factoring that denominator, what do we get?
It would be x plus negative 1. Wait, no. And then x minus 2.
Yes.
Okay.
You'd get your -3, and then a negative times a negative is going to get you your positive. So your 3 positive 2.
And then since the left side already has a -2, we just need times -1 to both, right?
Yeah. Why does it keep doing that? Don't do that. Okay. So we have I don't know why that's a 6. That's not helpful. -1 over x minus 1 times 2. X minus 2. All right. And then for the middle term, do we need to do anything?
No.
No. We're just going to rewrite it. It's equal. And what do we need to multiply this one by?
It's missing the x minus 2, so we need to multiply with that.
All right. And what do we get?
5x minus 10 at the top. And then the bottom is -1 parentheses negative x minus 2.
Yeah. And then for our first fraction, we get 2x minus 2 over x minus 1, x minus 2 minus 4 over x minus 1, x minus 2. All right, what do we do next?
We can now add subtract the 4 from the -2 because they have the same denominator now.
Yes. And what do you get?
2x minus 6.
Do we need to continue carrying around our denominator? Or can we multiply by our denominator and get rid of it on both sides?
Yes.
We can multiply by our denominator. Mostly because I don't want to continue writing it. Which those are going to each divide to 1. And we get 2x minus 6 is going to equal 5x minus 10. What do we do next?
We can do minus 2x plus 10 on the other side.
Yeah.
And then we need to divide by 3.
Do we want to check our solution? No. Okay. Our solution is 4/3.
Awesome. Cool. Before we move on to the last topic, is there any questions about solving with the fractions, equations?
Actually, yeah.
Yeah.
So once we times out everything, I usually just disregard the bottom half instead of timesing it out. Is that okay for mental math or no?
For mental math,
Yeah,
because
so-
you
So it's not.
have the same thing, so it makes sense because you're just trying to get the numerators to equal the same thing.
Mm-hmm.
You could technically carry around your your denominators the whole time, and they'll just multiply out. But yeah.
No, I'm saying like once I
Oh.
multiply them out and they're all have the same denominator, I just don't end up writing them out.
Yeah.
Yeah.
So you
Okay.
just don't.
That's-
Yeah.
You
Like
That
just
could be like an
multiply
issue.
by the denominator in your head.
Yeah.
Yeah.
Gotcha. Yeah.
yeah. That's fine.
Yes,
So yeah.
that's fine.
If you don't write out the this step right here of timesing everything by that common, as long as everything has the same common denominator,
Yeah.
then yeah, it's just multiplying out. You start dealing with the numerators. If you don't write that step,
Okay.
as long as you write everything else correctly, it's fine. So that's kind of topic that's covered in CBE 4 is solving radical equations. Radicals where you have like a square root or a cube root. Mostly in this class we're dealing with square roots, but it's similar concepts. Radical equations are equations with roots in them. So to solve them, similar to absolute values, we want to first isolate the radical, get it by itself, and then we're going to undo the radical with exponents. So if it's a square root, we're going to square the radical and square everything on the other side, solve the remaining equation. And then this one is actually where it's really important. We do in fact need to check your answers every time. Check your answers. Sometimes when squaring, we introduce extra solutions that are not true. So with radicals, normally we're going to get, if it's a square root, we're going to get 2 solutions. Sometimes both solutions are true. Sometimes only one solution is true. And you don't know unless you check it. So when you get to radicals, remember, no matter what, no matter if it's hard, and you're like, checking is going to be a waste of time, it's not a waste of time. So you got this equation right here. What is the first step in solving these radical equations?
Do we have to get rid of the x, right?
Yep, you need to get rid of the x so we can isolate the square root. I like to, when you isolate the square root, you want it to be positive. In this case, we got minus square root, so I'm actually going to add the square root to the other side. And then going to add this 2 to this side. So we're left with an x plus 2 equals square root of 2x plus 4. If you were to subtract the x over, it's totally fine. It just means that you're going to have to multiply everything by -1 before you continue. You don't want a negative square root. Cool. What is our next step in here?
Now that the root is by itself, we can square it.
Yep, we can square it. So we square this. And then when we square our left side, are we going to get like an x squared plus 4?
No.
No. What do we get?
X plus, I usually just do it like in factor form and then times it out.
Exactly, right? We're going to square that whole thing. So you're going to get an x plus 2 squared. Equals our radical goes away, so 2x plus 4. And then yes, then we're going to want to factor that out. X squared plus 2, when we factor that, we're going to get x squared plus a 2x plus a 2x. So that's going to be a plus of 4x plus 4. Still equal to 2x plus 4. Okay. What's our next step in solving this one? Now since we factor that out.
We can subtract the 2x over to the other side.
Exactly. 2x over. And then you also want to subtract that 4 over. Yes. So you could do it in 2 steps. You can do it in 1 step. But we have an x squared in there. So like previously, we want to set it all to 0. So we can use that 0 factor property to solve it. So we're going to get an x squared plus 2x plus 0 equals 0. Okay. What's our what step do we want to do now?
We can take out an x
Yep,
on the left side.
x plus 2 equals 0. Okay. And that is a factored form. Pulling out an x like that or a number is factoring it still. So we get this. Is there anything else we can factor from that? Okay. So is all factored? It's equal to 0. What are our two potential solutions for this one?
0 and -2.
Perfect. 0 and -2, right? If x is either one of those, they equal 0. Are we done?
Now we have to check.
Nope, we have to check, right? Radicals, we have to check. So let's check x equals 0 first. Okay, how do we check x is equal to 0?
We can plug it back into the original equation.
Exactly, plug it into the original equation. So we get 0 minus the square root of 2 times by 0 plus 4 equals -2. Okay. You go and solve this. We want to deal with what's in our radical first. So 0 minus it is 0. 2 times 0 is 0. So we're going to get the square root minus the square root of 4 equals -2. And what is the square root of 4?
It is 2.
It is 2. So we're going to get -2 equals -2. So 0 is one of our solutions. You go ahead and check x equals -2. Okay, so you're going to plug that into our 2. So we get -2 minus square root of 2 times by -2 plus 4 equals -2. What's our first step into simplifying this down to check it?
2 times -2 inside the square root.
Yep, want simplify our square root first. So we're going to get -2 minus 2 times -2 is -4 plus 4 equals -2. And the next thing we want to do?
Simplify -4 plus 4.
Exactly. Keep working in that. What is -4 plus 4?
0.
Easy. 0 equals -2. And what is the square root of 0? It's 0. So we're going to get -2 minus 0, which is 0, is nothing, equals -2. So that is in fact also a solution. So our final answer for this one is 0 and -2. Both of them did happen to be correct. But again, sometimes it may not be, and only one will be correct. Check that. That is correct. Awesome. I think that's it. There's some resources. Any questions?